Okay. Fundamental theorem of calculus, literally, this part one that our book at least rightly calls part one, is like the shortcut way to find all exact values for these definite integrals, okay? Do y'all remember from the 5-1 section, without those limits of integration, what do we do to find indefinite integrals? We took the what? Antiderivatives, correct. This capital F of x is an antiderivative of little f of x. Or, in other words, we could say capital F prime of x is equal to little f of x. Now, the one thing that will be missing in these definite integrals is the c. From when we did antiderivatives just without the definite integrals, we always had to put a plus c. And I will show you how this works and how the c's won't matter. Do you mean up like that? Okay. So now, without the definite integrals, what do we do from the 5-1 section to find the integral of x squared? Y'all remember the mantra we said? What do we do to the power? Add 1 to the power, divide by the new power, and then we did a plus c. And I'm going to show you this one time and one time only. We'll keep the c for a minute. What terminology-wise and what I'm looking for when I'm checking your work is we have the integral, right? This one we didn't have to do a rewrite, but we might rewrite it and we would keep the integral mark, right? But once we take the antiderivative, the integral mark goes away, and what we do for these definite ones is remind ourselves we got to go from 0 to 2. And some books will do a straight line, others do the little bracket. It's okay. And then we actually plug the top one in for the x minus the bottom one in. And notice, no matter what the c is, if I plug it in like that, distribute the negative sign, what will always happen to those c's? They'll cancel out. So guess what? Indefinite integrals, when we are doing definite integrals, we will never show the c. It's unnecessary because it would always cancel out. And 0 cubed is just 0. So 8/3 is our final answer. I'm just going to start throwing down more and more. Anybody remember the antiderivative of 1 over x? Oh, look at you. So, again, don't worry about a c. Write our little bracket. Once we take the antiderivative, no more integral marks, right? What do we plug in first? Top one first. Minus. Plug in the bottom. This would be a perfectly good free response answer. By the way, this would have been a perfectly good free response answer. Because don't take a chance of not multiplying a 2 times 2 times 2. or whatever. But this would absolutely be the multiple choice, so you've got to be able to simplify, okay? Even without a calculator. But anybody know what the natural log of 1 is? What power of e gives me 1? 0. So this would be the multiple choice answer. Multiple choice, free response. Just for funsies, we would have natural log absolute value of x from 2 to 3. We would have natural log of 3 minus natural log of 2, which really can't be reduced. However, what if that was not one of the multiple choice answers? Can anybody remember? Nope. Non-calculator multiple choice. ln of 3 divided by 2. Because of the rules of logs from pre-calc. Y'all remember those? Subtraction turns into division. All right. How about if it is what are we going to do on this one? Rewrite it. What would the rewrite be? Everybody good on the rewrite? So y'all liked the 5-1 thing for the most part, except for some of those obscure weird ones, right? Yeah, on the antiderivatives. What do we do for this one? Add 1 to the power would become 3 halves. Dividing by 3 halves is multiplying by, what would 1 go? I heard it, a whispered X. First trip through, what do we plug in? Top one. The top first. That's where a lot of people make their mistakes. Always top first, then minus the bottom, right? And also, they forget parentheses if they're doing it by hand. What answer would this be perfectly fine to leave it as? The free response. But multiple choice, you will be asked to take 4 to 3 halves. What does the bottom mean? The square root of 4 is 2. 2 cubed, 8 times 2 is 16 thirds minus 4. 1 to any power is just 1, so distribute that negative times 2 thirds. Negative times negative would be plus 1. What's 16 thirds minus 2 thirds? 14 thirds minus 3, which is actually 9 thirds, right? 5 thirds would be the multiple choice answer. Did I do something wrong? Negative 4 plus 1 is negative 3 times 3 over 3 would give us 9 thirds, right? 14 minus 9 is 5. Shall we check it on the calculator just to make sure? 5 thirds is what? 1 and 2 thirds? Would be nice if I had one with batteries. Math 9. I did show you how to do it, right? Square root of x minus 1. .6 repeating is 1 and 2 thirds, isn't it? 5/3. All right, everybody feel good about that? Let's see if we can make it any more difficult. Let's do a couple transcendental ones.
I can't. I don't want to be a girl.
So this one's going to be our star difficult.
Stop flipping me off. I'm sorry. Why don't you do it? Oh, like me. Oh. Bro, I've been everybody like thinking, no toilet bed. What? I had one quarter.
All right. Guys, what should we do to rewrite number 1? X to the negative 1/2. I get that x, the square root of x on the bottom, calling it x to the negative 1/2. What about the, I mean, everybody understands this is the same as the square root of 2 over the square root of x, right? What could I officially do with that square root of 2 if I wanted to? Call it just a coefficient. It's just a number, right? As long as it does not have an x in it, I'm free to just pull it out on the outside. And then I don't have to deal with it until the end. Everybody good with that? Remember that rule we did? If you have a constant, just pull the constant on the outside. Now take off. Can you do the antiderivative? Add 1 to the power of b. Dividing by 1/2 is multiplying by 2. We still have the square root of 2. So I'm going to keep that 2 root 2 out, factor it out, and then I'm just going to go 8 to the 1/2 minus 1 to the 1/2. Does that make sense?
Then you can leave that for free response, right?
Free response, we could leave it. Am I going to allow you to leave everything in free response? No, because there will be some multiple choices. What does 8 to the 1/2 mean? The square root of 8. And 8 is what? 2 times 2 times 2. Would you agree that that would be a 2 square root of 2?
Yes.
Multiplying by the 2 square root of 2, what's that going to give us? It's going to give us a 4 times a plane 2, isn't it?
Oh, 8.
It's going to be 8
7.
minus, we still distribute 2 root 2. This would be the multiple choice version.
Wow, that's a lot.
Everybody understand how we got the 8? 2 times 2 is 4. Square root of 2 times square root of 2 is 2. 4 times 2, 8. And then I just
Wait, but how do
distributed.
you have another one?
I distributed.
Oh, yeah, yeah.
The square root of 1 is just 1. All right. I'm going to leave number 2 until the end. because it is by far the hardest.
Do we get out of this class at 11:30 or 11:35?
11:35. I just looked it up. All right, what do we do with these ones that look like quotients? We've already said there's no quotient rule. We split it up. As long as there's one term on the bottom. What's x over x? 1 plus 1 over x. Antiderivatives will be x plus what? Natural log absolute value of x. What do we plug in first? 8 plus natural log of 8. What do we plug in next?
1.
Plus natural log of 1. Free response it would be fine. Only if it's a free response question, right? Anybody know the natural log of 1?
0.
0. 8 minus 1 would be 7. This would be the multiple choice. I mean, I don't think, can anybody go back to pre-calc just in case they decided to be tricky? 8 is 2 to the 3rd power. What do you do with powers? Just in case they're being stinky. Oops, the power was 3. 3, ln of 2. I've been talking to my grandson. Hush up. I call him stinky all the time.
I thought you called him Julia. What do you call him?
Joodle cakes.
Julia.
Because I always sing Joodle cakes, Joodle cakes, Joodle cakes, Joodle cakes. I have to. All right. What is T? Oh, I did that on the recording. What does T go to? Squared over 2. Now there's one of those transcendentals. The antiderivative of e to the t is just plain old e to the t. What do we have to do with the something other than the e? Divide by natural log of the base. First trip through, which one are we plugging in?
3.
The 3, top one. 3 squared over 2 minus 5 cubed over ln 5 minus. Now, I'll be honest, my tendency with zeros is to go, oh, just a big 0, because we're plugging in zeros. However, this first one is 0, but what is 5 to the 0? 1. Free response it, or 3 squared 9/2 125 over natural log 5 plus 1 over natural log 5 would give us minus 124 over natural log 5. What's the antiderivative of 2? Dx.
No,
2x. Anybody remember what function has a derivative of negative cosine squared? What?
Wait, what?
Mm-mm.
Son?
The derivative of sine is regular cosine, right? Derivative of tangent is secant squared. You're closing in on it. Cotangent. And by the way, it's regular cotangent, and the derivative of cotangent is negative cosecant squared, right? Good call, Sydney. All right. First time through, what are we plugging in? The pi over 2. minus, use parentheses very carefully and deliberately. If you don't use a parentheses around this, your free response would not be correct. So that is the one beauty of a free response with those trig functions. But I've seen trig functions on multiple choice as well. What's 2 times pi over 2? Pi. Anybody know the cotangent of pi over 2?
1.5.
Is it undefined?
4.
The tangent of pi, no.
1.
Tangent of pi over 2 is undefined.
Oh, 0?
Cotangent of pi over 2 is 0. What happens with the 2 and the 4? Cancels 1/2 minus the cotangent of pi over 4 now is a 1, right? Pi over 4 is a 45 degree. Both the adjacent and opposite are the same, so it's 1. What's pi minus pi over 2? There's our multiple choice answer. Whew.
So is this last one?
Actually, 5.5. I want to show you something. What if I had 0 to pi over 4 of 1 minus sine squared theta over cosine squared theta d theta? At first glance, this looks horrible, doesn't it?
Oh wait, but that's just cosine squared.
1 minus sine squared is just
Cosine squared.
cosine squared.
Or easy in there.
And what's cosine squared over cosine squared?
1. Or 1 easy in there.
Instead of being a difficult problem, what's the antiderivative of 1 d theta?
X?
Theta, in this case, right?
Okay, you good.
Plug in the top, pi over 4, minus 0. So it looked difficult to start with, but not really, if you remember your... Now, if you had me in pre-calc, and we were dealing with absolute values, does anybody know what I told you to turn them to?
No way.
Piecewise functions, every time. So, what is the changeover value? What's the value that x can be and you know it'll always be positive? Or equal to 4. So, for the x is greater than or equal to 4, that thing is already positive, so what would I replace that with? I'd say 3 minus plain old x minus 4, correct? Distribute the negative. I'm seeing a 7 minus x. Is that what you're seeing? But for the x's that are less than 4, what would I have to replace that thing to make sure I made it positive? The opposite. But minus and negative would be the same as positive. So are you seeing x minus 1 for this one? So if I am taking an integral from 2 to 5, then I'm just going to split it up, and I'll go 2 to 4 first and use the bottom piece and add it to what? 2 to 4. What do we have to complete it? 4 to 5. And that one, I'll use the top piece. Too fast, or are we okay? Did you ever, I'm pretty sure Paysor talked about piecewise functions, right?
Maybe twice.
You were online. Did y'all do it online?
I remember
Yeah. Antiderivative, plug in the top, 4 squared, minus parentheses, plug in the bottom, plus 7x minus x squared over 2, plug in the top, 7 times 5 minus 5 squared over 2, minus 7 times 4 minus 16 over 2 is 8. There is the free response. Can anybody help me? What's 14? What's 4 squared? 16 over 2, 8. 2 squared is 4 over 2, 2. Minus a negative would be plus 2. 35 minus 25 over 2 minus 20. 4 minus 2 is 2, plus 2 is 4. 4 plus 35, 39. 39 minus 20, 19. Minus 25 halves, 38 halves. Minus 25 halves would be hey, let's test. See if we got it right from the start. 2 to 5, 3 minus absolute value, x minus 4. 6.49999 is 6.5. Is 13 halves 6.5? Yes. All right, your assignment is on Blackboard. Do y'all need to see it?